In this journey through the deepest reaches of the cosmos, we explore the silent forces currently dismantling everything we know, beginning with the terrifying reality that the space between us is no longer a passive backdrop, but an active predator. Right now, something is erasing the universe. It is happening in the silence between your heartbeats and in the vast, cold stretches between the stars, between every galaxy, star and atom. Space is expanding faster than light itself. Scientists call it dark energy, and it makes up 70% of everything that exists. We are living in a cosmic ocean where islands of matter are drifting apart, never to reunite. You will journey through voids so massive they should not exist. Discover why we see no alien civilizations and learn what waits at the end of time. If you are ready to see how terrifying emptiness truly is, welcome to the Whispering Scientist. Brace yourselves. We descend into the void. Look around you. Everything you see, everything you touch, every person you know exists because of matter. Your body, this planet, every star burning in the night sky is a testament to the presence of something. But here is what scientists confirmed through decades of observation. All of that combined, every mountain, every ocean, every burning sun, makes up less than 1% of the universe. The rest is void. Imagine taking every galaxy we can observe, every billion stars they contain, every planet orbiting those stars, and crushing them together into a single point. You would fill less than a trillionth of the space that exists. The universe's average density is about 6 hydrogen atoms per cubic meter. Think about that for a moment as you breathe. Walk into an empty room and you are breathing in billions more particles than what fills the same volume in deep space. This emptiness is not random. It is structured, intentional, and growing. Measurements from the Planck satellite and the Hubble Space Telescope reveal that matter clusters in thin filaments and walls, like a cosmic web. Between these structures stretch regions so empty they make the space between stars look crowded. Astronomers call them voids, and they dominate everything. Think of the universe as an ocean. Galaxies are not scattered evenly like salt dissolved in water. They gather in tiny foam bubbles floating on the surface while massive bubbles of nothing sit underneath. You live inside one of those foam specks, surrounded by darkness so complete it swallows light. Why does this matter to you? Because the emptiness is growing. Every second, space itself expands, pushing those bubbles of nothing wider. The galaxy clusters sitting at the edges of voids are accelerating away from each other, driven by a force we barely understand. That force is dark energy, and it fills the void with something stranger than empty space. Scientists measuring distant supernovae discovered in 1998 that expansion is accelerating. This was not supposed to happen. Gravity should slow everything down, pulling matter back together in a grand cosmic embrace. Instead, something in the void is overpowering gravity itself. The emptier a region becomes, the stronger this force grows. You exist in a brief window where stars still shine and galaxies cluster close enough to see. But the void is winning. With every passing moment, more space opens between islands of matter. Eventually, the darkness will separate everything so completely that entire galaxies will vanish beyond reach, swallowed by expanding nothingness. What lives in that void is still a mystery. What we know for certain is this: emptiness is not passive. It is active, aggressive, and spreading. But the true scale of this void is something you cannot imagine yet. The larger structures we can map are not clusters of galaxies. They are the void between them. In 2004, astronomers completed the Sloan Digital Sky Survey, a project that mapped over 1 million galaxies across billions of light years. What they found defied expectations. Galaxies formed thin threads and sheets surrounding enormous bubbles of almost pure vacuum. Some of these bubbles measured over 1 billion light years. To cross one of these voids at light speed would take longer than Earth has existed. Light that began its journey when dinosaurs walked. This planet would still be crossing empty darkness today, seeing nothing but the cold, thin stretch of a vacuum that refuses to end. These are not small gaps between neighborhoods. These are chasms that separate entire regions of the cosmos. Inside a typical void, you would find perhaps one galaxy per every 10 million cubic light-years. Compare that to our local neighborhood where dozens of galaxies crowd within a few million light-years. The difference is staggering. You could fit millions of galaxy clusters inside a single void, yet most contain almost nothing. Scientists using supercomputers ran simulations of cosmic evolution. They started with the conditions moments after the Big Bang and let gravity do its work over billions of years. The simulations produce the same web-like pattern we observe. Matter naturally collapses into dense filaments, while voids expand between them. This is confirmed science validated by multiple independent studies. But here is where things become unsettling. The voids are growing faster than the simulations predicted. Dark energy is not just maintaining these empty regions, it is actively inflating them, pushing their walls outward at accelerating speeds. Measurements from the Dark Energy Survey show that voids expand roughly 10% faster than expected, based on gravity alone. What does this mean for you? Every galaxy sitting on the edge of a void is being pulled in two directions. Gravity tries to keep it connected to nearby galaxies. Dark energy tries to drag it into isolation. Now, gravity still wins in dense regions. But in the voids, dark energy dominates completely. Think about standing at the edge of an expanding chasm. The ground beneath neighboring towns is moving away slowly at first, then faster. Eventually, the gap becomes too wide to cross. That is happening to galaxy clusters across the universe. The voids between them are becoming permanent barriers, dividing the cosmos into isolated kingdoms that will never communicate again. Emptiness is not in the distant future. It is here, surrounding us, growing every moment. It is the silent erasure of proximity. We often think of space as a stage where the drama of the stars plays out, but the stage itself is now stretching, pulling the actors so far apart that the play can no longer continue. This introduction to the void is only the first step. To understand the true nature of this erasure, we must look at the specific structures that define this nothingness. We must look at the great nothing, the super voids that challenge our understanding of physics. As you listen, feel the scale of this distance. Imagine the light traveling for eons through a space that contains nothing to reflect it, nothing to warm it, and nothing to stop it. This is the reality of our home. We are the 1% clinging to the edges of a vacuum that is slowly but surely claiming its territory back. The silence of the universe is not an absence of sound, but the presence of an expanding, active nothingness that is steadily moving to isolate us in the dark. In this exploration of the deep cosmos, we shift our focus from the broad expansion of the void to the fragile structures that still manage to cling together in the dark. Imagine, if you will, the universe as a vast and restless ocean, an infinite expanse of liquid shadow where the only signs of existence are tiny, scattered islands of light. These islands are the galaxies, the great star cities where matter has gathered to defy the encroaching nothingness. But as we look closer at this cosmic ocean, we realize that the water, the empty space, is rising, and our islands are drifting further and further apart. In this chapter, we descend into the mechanics of this isolation, observing how the very structure of the universe is designed to keep things separate. The beauty of the night sky is a temporary mask for a deeper, more permanent loneliness that defines the fabric of reality. The average person looks up at the stars and sees a crowded sky, but this is a trick of perspective. We are huddled in a rare pocket of density. If you were to be teleported to a random location in the universe, the odds of you being inside a galaxy are practically zero. You would most likely find yourself in the intergalactic medium, a place so empty that a single atom might be your only companion for miles. Scientists have spent decades mapping this distribution, trying to understand why matter clusters the way it does. What they found is the cosmic web, a delicate and beautiful arrangement of filaments made of dark matter and gas. Galaxies are like dewdrops clinging to the strands of a spider's web. Between those strands, however, are the great bubbles of nothing we discussed previously. These bubbles, or voids, are not just empty, they are the true face of the universe. Matter is the anomaly, the void is the rule. When we speak of these islands in the dark, we must acknowledge the sheer scale of the separation. Consider the distance between our own Milky Way and our nearest large neighbor, Andromeda. They are separated by 2.5 million light-years of space. To us, that seems like a bridge gap, especially since gravity is currently pulling us together. But look beyond our local group, and the gaps become chasms. The space between galaxy clusters is so vast that light itself becomes tired as it crosses the distance, stretching into longer, redder wavelengths. This redshift is the first warning sign that the ocean is growing. The farther a galaxy is from us, the faster it appears to be moving away. This isn't because the galaxy is traveling through space like a ship, but because the space between us is literally being manufactured. Every second, more ocean is added between the islands, pushing them toward an inevitable horizon where they will disappear from our view forever. Astronomers use the term large-scale structure to describe how these islands are organized. It is a hierarchy of light. Stars form galaxies, galaxies form groups, groups form clusters, and clusters form superclusters. We belong to the Virgo supercluster, a massive collection of thousands of galaxies. From the outside, it looks like a vibrant city of light. But even within this supercluster, the voids are beginning to exert their influence. The outer edges of the Virgo supercluster are already beginning to fray. The gravity that holds it together is a finite force, a tether that can only stretch so far. Dark energy is like a pair of invisible scissors slowly snipping those tethers. One by one, the furthest islands are being released into the current of the expanding void. They are drifting away, destined to become solitary wanderers in a universe that is becoming increasingly hostile to the community. What is it like to live on one of these islands as the ocean rises? For now, we are privileged. We can look and see the glow of other galaxies. We can measure their speeds and study their compositions. But this is a window that is slowly closing. Imagine being on a ship in the mid-glare of the night. You see the lights of other ships on the horizon. You feel a sense of comfort knowing you aren't alone. But then, you realize the lights are getting dimmer. One by one, they slip past the horizon, not because they have turned off their lamps, but because the distance has grown too great for the light to reach you. Eventually, you are left in total darkness, with nothing but the stars on your own deck to keep you company. This is the future of every inhabitant of the cosmic ocean. We are witnessing the last era of connectivity. The islands are being swallowed by the scale of the space between them. The terror of this emptiness is found in its passivity. The void doesn't scream, it doesn't attack, it simply exists and expands. It is a slow-motion erasure. Scientists have noted that the density of matter in the universe is so low that if you were to distribute it evenly, it would be like having one grain of sand in a volume the size of the Earth. It is only because gravity is so persistent that we have islands at all. Gravity is the architect that built the star cities, but it is an old architect, and its strength is failing against the relentless tide of dark energy. We are living in the wreckage of a cosmic battle between the pull of matter and the push of nothingness. And as we map the furthest reaches of the observable universe, we see that the nothingness has already won the majority of the territory. The islands are small, fragile, and temporary. As you drift closer to sleep, consider the silence of those intergalactic gaps. There is a peace in that silence, a stillness that matter cannot achieve. In the heart of a galaxy, things are chaotic. Stars are exploding, black holes are consuming, and planets are colliding. But in the void, there is only the smooth, cold expansion of space-time. It is the ultimate equilibrium. Perhaps that is why the RSE is moving toward emptiness. It is seeking a state of perfect rest. The islands of matter are like fever dreams of the cosmos, pockets of heat and energy that will eventually burn out and be reclaimed by the cool, dark ocean. We are part of that dream, a brief flicker of awareness on a speck of dust, watching as the lights of the other islands fade away into the permanent night. The isolation of these islands isn't just a physical distance, it is a temporal one as well, because light takes time to travel. When we look at a distant island, we are looking into the past. We see it as it was, not as it is. In a sense, we are surrounded by ghosts. The galaxy we see at the edge of the observable universe might have already drifted beyond the event horizon in its own present time. We are seeing its afterimage, a lingering memory of a neighbor that is already gone. This realization adds a layer of haunting beauty to the cosmic ocean. We are looking at a graveyard of light, where the images of islands continue to reach us long after the islands themselves have been carried away by the expanding current. The ocean is vast, the night is long, and our island is smaller than we ever dared imagine. In this third stage of our journey, we must confront the primary antagonist of the cosmic story, the invisible hand that is currently reaching across the billions of light years to pull the stars apart. We often think of empty space as a vacuum, a hollow container where things happen, but the reality is far more disturbing. Space is not nothing, it is a substance with its own energy, a hidden pressure that has spent the last several billion years asserting its dominance over the material world. This force, which we have come to know as dark energy, is the reason the universe is empty, and it is the reason it will stay that way. It is the aggressive force of nothingness, an energy that thrives on the very void it creates. As we peel back the layers of this mystery, we begin to see that the universe is not just expanding, it is being torn from within by a ghost that makes up the vast majority of our reality. To understand dark energy, we have to look back to the year 1998, a turning point in the history of human knowledge. Before this moment, astronomers believed they understood the basic fate of the cosmos. They knew the universe was expanding because of the initial kick of the Big Bang, but they assumed that gravity, the collective pull of every star and galaxy, would eventually act as a cosmic brake. The debate at the time was simply whether the universe would expand forever at a slower and slower rate, or if gravity would eventually win, pulling everything back into a fiery collapse known as the Big Crunch. To settle this, two independent teams of scientists set out to measure the brightness of distant supernovae, using them as cosmic milestones to track how much the expansion had slowed down over time. What they found instead sent shockwaves through the scientific community and fundamentally altered our understanding of existence. The expansion wasn't slowing down at all, it was speeding up. Imagine throwing a ball into the air. You expect it to slow down as it rises, eventually stopping for a split second before falling back to your hand. Now imagine that same ball leaving your hand and suddenly accelerating, screaming upward into the sky faster and faster until it vanishes from sight. This is what our universe is doing. This unexpected acceleration required a new explanation, a source of energy that pushed outward against the inward pull of gravity. Scientists resurrected a discarded idea from Albert Einstein, the cosmological constant, and gave it a new, more mysterious name, dark energy. We call it dark not because of its color, but because it is utterly invisible. It does not emit light, it does not reflect it, and it does not block it. It is a property of space itself, a constant energy density that fills every cubic centimeter of the vacuum. The scariest property of dark energy is how it scales with the universe. In the world of matter, density is a simple concept. If you have a box of gas and you double the size of the box, the gas becomes half as dense, the matter is spread thinner. But dark energy does not follow these rules. As the universe expands and creates more space, it creates more dark energy. It does not dilute. Every new patch of void that appears between two galaxies comes preloaded with its own supply of this repulsive force. This creates a feedback loop that the universe cannot escape. More expansion leads to more space leads to more dark energy, and more dark energy leads to even faster expansion. It is a runaway process, a self-fueling engine of isolation. Early in the history of the cosmos, matter was packed tightly together, and gravity was the king. But about 5 or 6 billion years ago, the universe became large enough that the total amount of dark energy began to outweigh the total amount of matter. The transition was silent and invisible, but it marked the moment the void took control of our destiny. If you were to look at a pie chart of everything in the universe, the results would be humbling. All the stars, planets, nebulas, and life forms, everything we can see with our eyes and telescopes, make up a meager 5% of reality. Another 25% is dark matter, a mysterious substance that helps hold galaxies together. But the remaining 70% is dark energy. We are the minority. We are the small, shivering embers in a cold, vast room filled with a force that wants us gone. Dark energy acts like a cosmic wind, blowing the galaxy clusters away from one another. In our daily lives, we don't feel it because the gravity of the Earth is strong enough to keep our feet on the ground, and the gravity of the Sun is strong enough to keep the planets in orbit. But on the largest scales, where gravity is weak and the distances are measured in millions of light years, dark energy is the undisputed master. It is effectively erasing the connections between the great structures of the cosmic web. This force is aggressive because it is relentless. It does not tire, it does not fluctuate, and it does not seem to have an expiration date. It is a fundamental tension in the fabric of the vacuum. Some physicists suggest that dark energy might be the cost of having space. To have a volume of three-dimensional reality, you must pay a price in the form of this inherent energy. As long as there is space, there will be dark energy. As long as there is dark energy, the universe will continue to grow emptier. We often use the word empty to describe a room with no furniture, but a room with no furniture still has air and light. The cosmic void is truly empty of matter, yet it is teeming with this dark pressure. It is a strange paradox. The emptier the universe gets, the more energy it contains. The nothingness is not a lack of something, it is a presence of something else, something that is actively hostile to proximity. As you listen to the rhythmic pulse of these words, try to visualize the invisible tide rising. It is moving the distant galaxies further into the darkness, pushing them toward a point of no return. This isn't just a mathematical theory, it is a measured reality, confirmed by the cosmic microwave background and the large-scale mapping of the sky. We are living in an era of transition. We can still see the neighbors, but the road between us is stretching. Dark energy is the reason why the future of the universe is a grand reunion, but a silent, cold dispersal. It is the ultimate isolator, a force that ensures every part of the cosmos will eventually be alone, surrounded by a void that it helped to create. This is the aggressive nature of the nothingness. It doesn't just wait for the light to go out, it actively pushes the light away. We are adrift in a sea of dark energy, and the shore is disappearing faster every second. The mystery of what dark energy actually is remains the greatest unsolved problem in physics. Is it vacuum energy, arising from quantum fluctuations? Is it a new type of field that permeates the universe, sometimes called quintessence? Or is it a sign that our understanding of gravity itself is flawed on the largest scales? Whatever the answer, the result is the same. The universe is being hollowed out. The structures that took billions of years to form are being systematically separated. Dark energy is the architect of the great emptiness, the invisible hand that is turning the lights out on the cosmic stage. As we move into the deeper chapters of this story, remember this force. It is the background hum of the universe, the silent pressure in the dark, and the reason why, in the end, there will be nothing left but the void. In this fourth chapter of our descent into the cosmic vacuum, we move away from abstract theories and into the realm of hard observational evidence. To understand the true shape of the universe, we cannot simply look at a single star or even a single galaxy. We must look at the map of everything. For decades, our view of the cosmos was like looking at a dense forest through a keyhole, seeing only a few trees and assuming the entire world was made of wood. But with the advent of the Sloan Digital Sky Survey, we finally opened the door and stepped outside. What we found was not a uniform forest, but a hollowed-out landscape of gargantuan bubbles. This project, one of the most ambitious in the history of science, changed our perspective forever by showing us that the universe is not defined by where the light is, but by the massive, terrifying spaces where it is not. As we analyze these maps, we begin to see the cosmic bubbles, the true architecture of the night. The Sloan Digital Sky Survey, or SDSS, began its work at the turn of the millennium, using a dedicated wide-angle telescope at the Apache Point Observatory in New Mexico. Its goal was simple, yet staggering, to create a three-dimensional map of the universe that covered more than a quarter of the sky. By measuring the positions and distances of over 1 million galaxies, the survey allowed us to see the large-scale structure of the cosmos for the first time in high definition. Imagine the patience required to pinpoint 1,000,000 points of light across billions of light years. As the data poured in, a pattern began to emerge that looked less like a random distribution of matter and more like a delicate biological sponge. This is what astronomers call the cosmic web. In this web, galaxies are not scattered like dust. They are arranged into thin glowing filaments and vast flat sheets that intersect at dense points known as nodes or clusters. But the most striking feature revealed by the SDSS was not the web itself, but the holes within it. These holes are the cosmic voids, the bubbles of nothing that occupy the vast majority of space. Before the Sloan survey, we knew that galaxies clustered together, but we had no idea how enormous the empty spaces between them could be. The map showed that the filaments of galaxies serve as the walls of these bubbles, enclosing regions of space that are almost entirely devoid of matter. Some of these bubbles are 50 million light-years across, while others, the supervoids, stretch for hundreds of millions or a billion light-years. To put that in perspective, our own Milky Way galaxy is about 100,000 light-years wide. You could fit tens of thousands of galaxies like ours inside a single one of these bubbles. And yet, in many of them, there is nothing. No stars to light the way, no planets to harbor life, and no gas to breathe. Just a pure, unadulterated vacuum stretching into the distance. Mapping these bubbles is like mapping the shadows in a dark room to understand where the walls are. By observing where galaxies refuse to go, scientists have been able to calculate dark energy's influence with unprecedented precision. The Sloan Digital Sky Survey proved that these voids are not just accidental gaps. They are the result of a multi-billion-year tug-of-war. After the Big Bang, the universe was nearly smooth, but tiny ripples in density caused gravity to pull matter together into the filaments we see today. However, as matter collapsed into these walls, the space between them grew emptier. Once these regions became thin enough, dark energy took over, inflating the bubbles like balloons. The SDSS data confirmed that these voids are expanding at an accelerating rate, pushing the walls of galaxies further apart. We are watching the universe hollow itself out in real time, one bubble at a time. As you listen to the steady flow of these cosmic revelations, imagine flying a spacecraft through one of these Sloan-mapped voids. At first, as you leave the filament of your home galaxy, you would see the distant glow of other star cities behind you. But as you move deeper into the bubble, the lights would begin to fade. Because the void is so vast, the nearest galaxy would eventually be so far away that it would appear as nothing more than a dim, lonely smudge on the horizon. Eventually, even those smudges would disappear. You would be in a region of space so dark that there would be no difference between opening your eyes and closing them. There would be no starlight to guide you and no heat to warm your hull. You would be a speck of dust in a billion light-year chasm of nothingness. This is not science fiction. These are real locations mapped by our telescopes, vast deserts of space that occupy most of the volume of our universe. The SDSS also revealed that these bubbles have a profound effect on the light traveling through them. When light from the early universe passes through a massive void, it has to climb out of a gravitational well. Because there is so little matter in the void, the light loses energy as it exits, becoming stretched and cooled. This phenomenon, known as the integrated Sachs-Wolf effect, provides a fingerprint of the void on the cosmic microwave background radiation. By comparing the maps of galaxies from the Sloan survey with the temperature maps of the early universe, scientists have confirmed that these bubbles are growing even faster than gravity alone would allow. It is as if the voids are actively repelling matter, clearing their interiors of any stray atoms and pushing everything toward the edges. The bubbles are winning the battle for space. What the Sloan Digital Sky Survey ultimately taught us is that we live on the surface of a bubble. Our local group of galaxies is perched on a filament that borders several large voids. We are like inhabitants of a small village built on a narrow ridge between two bottomless canyons. We look out and see the lights of other villages on distant ridges, but we now know that the canyons between us are widening. The map of the universe is a map of increasing isolation. The SDSS didn't just show us where the galaxies are, It showed us the scale of our loneliness. It provided the skeletal structure of a cosmos that is being stretched to its breaking point. Every POI, NT of light recorded by the survey, is a witness to the expanding nothingness, a tiny spark held against an encroaching tide of blackness that is billions of light-years wide. As we conclude this chapter of mapping, take a deep breath and feel the weight of that scale. The bubbles are not just out there in the distant sky, they are the environment in which our entire history has unfolded. The voids mapped by the Sloan survey are the dominant feature of our reality. They are the great silent cathedrals of the cosmos, spaces where time and expansion reign supreme over matter and light. We are the 1%, the thin film of matter clinging to the walls of a universe that is mostly made of bubbles. In the next chapter, we will zoom in on one of the most famous and terrifying of these bubbles, a place where the darkness is so absolute it has earned the name of the Great Nothing. But for now, let the image of the cosmic web rest in your mind, a delicate lattice of light surrounding endless, expanding voids. In this 5th chapter of our descent, we move away from the general maps of the cosmic web and turn our gaze toward a specific, haunting anomaly that challenges our understanding of how the universe was built. If the cosmic bubbles we have discussed so far are the rule, then the region we are about to enter is the most extreme expression of that rule. In 1981, astronomer Robert Kirshner and his team discovered something that should not exist according to the standard timeline of cosmic evolution. While mapping galaxies in the direction of the constellation Bootes, they found a region of space so devoid of matter, so profoundly empty, that it earned the name the Great Nothing. This is the Bootes Void, a spherical chasm of darkness measuring 330 million light-years across. It is a place where the lights of the universe have been systematically extinguished, offering us a terrifying preview of what the entire cosmos will eventually become. As we drift into the heart of this supervoid, the scale of the isolation becomes more than a number. It becomes a physical presence. To understand why the Bootes Void is so unsettling to scientists, we have to look at the math of the early universe. In a typical region of space of this size, we should expect to find roughly 10,000 galaxies, each teeming with billions of stars and planets. But in the Great Nothing, we have found only 60%. That is a 99.4% vacancy rate. If our own Milky Way galaxy were located in the center of this void, we would have lived for most of our history believing we were the only galaxy in existence. Our astronomers would look out with their most powerful telescopes and see nothing but blackness in every direction. They would not have discovered other galaxies until the 1960s, and even then, those neighbors would be so dim and distant that they would appear as mere ghosts on the edge of detection. The Bootes Void is a kingdom of silence, a place where the cosmic web has been torn apart, leaving only a few scattered survivors drifting in a sea of absolute nothingness. The existence of such a massive vacuum is a direct violation of the standard cosmological models. According to the laws of gravity, there hasn't been enough time since the Big Bang for matter to be evacuated so completely from such a large volume. Gravity is a slow worker. It pulls matter into clusters and filaments, but it usually leaves a few stragglers behind. The Bootes Void, however, is too clean. It is as if some force more powerful than gravity has swept the area, pushing every atom and every photon toward the distant edges. Some physicists theorize that the Bootes Void was not born as one large bubble, but rather formed from the merging of several smaller voids, like soap bubbles joining together in a sink. But even this explanation struggles to explain the sheer perfection of its emptiness. It stands as a silent witness to the power of dark energy, showing us what happens when the expansion of space is allowed to run wild, unchecked by the presence of matter. Imagine, for a moment, the perspective of a civilization living in one of those 60 lonely galaxies trapped inside the Great Nothing. Their night sky would be terrifyingly different from ours. We are used to seeing a band of light from our own galaxy and the distant smudges of our neighbors, but for them there would be no neighbors. Their telescopes would point into a vacuum that extends for 150 million light-years in every direction before meeting the first sign of another star city. They would grow up in a universe that feels finite, small, and utterly empty. They would have no way of knowing about the vibrant cosmic web that exists beyond their walls. They are the ultimate prisoners of the void, isolated not by walls of stone, but by the sheer, insurmountable scale of the nothingness surrounding them. This is the isolation that dark energy is currently preparing for us all. The Boots void is not an anomaly, it is a destination. As you sink deeper into relaxation, let the silence of the Boots void wash over you. There is no sound in space, but here, even the light feels quiet. This supervoid is a preview of the heat death we will discuss in later chapters. It is a region where the energy density has dropped so low that almost nothing can happen. No new stars are forming in the center of the void because there is no gas to fuel them. No civilizations are communicating because there is no one to listen. It is a preview of the end of time, a place where the universe has already finished its work and has settled into a permanent frozen state of rest. When we look at the Boots void, we are looking at the future of the Milky Way. We are looking at a time when the space between us and our neighbors has grown so vast that we too will live in a night sky of utter darkness. The sheer size of the great nothing, 330 million light-years, is difficult for the human mind to grasp. To cross it at the speed of light would take longer than the time since the first multicellular life appeared on Earth. If you started a journey across the void when the first creatures crawled out of the oceans, you would still be traveling today, and you would still be millions of light-years away from the other side, and for the entirety of that journey you would see nothing. No stars passing by your window, no nebulae glowing in the distance, just a flat, featureless vacuum. This is the terrifying emptiness that the title of our journey promised. It is the realization that the universe is not a place built for us. It is a place built for the void, and we are merely the thin, temporary inhabitants of its unfinished corners. Why does the Boots void exist? Some suggest it is evidence of a variation in the strength of dark energy. If the force tearing space apart is stronger in certain regions, those areas would hollow out much faster than the rest of the cosmos. If this is true, it means the universe is not uniform. It means there are pockets of space where the destruction of proximity is happening at a specialized, accelerated rate. We are fortunate to live in a relatively crowded neighborhood for now, but the walls of the Boots void are expanding. It is consuming the filaments that surround it, pulling the galaxies on its edges into the darkness. It is a cosmic predator, a mouth of nothingness that is slowly eating the light of the universe. As we conclude this chapter, reflect on the 60 galaxies that still remain in that darkness. They are like the last embers of a dying fire, holding out against a night that is billions of times larger than they are. They represent the resilience of matter, but they also represent its futility. Eventually, even those 60 galaxies will be pushed so far apart by the expansion of the void that they will lose sight of one another. The great nothing will become the perfect nothing. This is the lesson of Boots. The universe does not want to be full. It wants to be empty. It is erasing its history, its structure, and its light, and it is using the voids as its canvas. We are simply watching the first sections of the map turn to black. In this 6th chapter of our journey into the deepening shadows, we must confront a boundary that is as absolute as it is invisible. We often think of the universe as a vast room where, if we only waited long enough or built a powerful enough telescope, we could eventually see everything. We imagine that light, the fastest messenger in existence, will always find its way to us eventually. But the terrifying reality of an expanding universe is that there is a wall, not a wall of stone or fire, but a wall of distance, beyond which the light is simply moving too slowly to win against the growth of space. This is the cosmic event horizon. It is the point of no return, a threshold where the universe is being erased in real time. As we descend into this concept, we realize that our view of the cosmos is not just limited, it is actively shrinking. We are being quarantined by the very fabric of reality, and the gates are closing. To understand the cosmic event horizon, we must first look at the unique way space behaves. According to Einstein's theory of relativity, nothing can travel through space faster than the speed of light. This is a fundamental law that governs every atom and every photon. However, this law does not apply to space itself. Space can stretch, expand, and grow at any speed it chooses. Because the universe is infused with dark energy, the space between distant galaxies is expanding at an accelerating rate. The further away a galaxy is from us, the more space there is between us to expand. Eventually, you reach a distance where the cumulative expansion of space is happening faster than the speed of light. At this point, even if a star in that distant galaxy emits a beam of light directly toward Earth, that light will never reach us. It is like a swimmer trying to reach a shore, while the river between them flows backward at twice their swimming speed. No matter how long they swim, no matter how hard they fight, the shore only gets further away. This boundary, currently sitting roughly 16 billion light-years away, is the cosmic event horizon. It represents the limit of our future. Any event that happens beyond this line today will stay hidden from us for all of eternity. Any signal sent, any star born, any civilization that rises to greatness beyond that horizon is effectively non-existent to us. They are not just far away, they are causally disconnected. This is the ultimate form of cosmic erasure. The universe is not just growing, it is tearing itself into isolated pockets of reality that can no longer communicate with one another. We are living in a bubble of causality, and the walls of that bubble are made of the sheer, impossible speed of expanding nothingness. Every second that passes, more of the universe crosses this line, slipping into a permanent, unreachable darkness. Imagine standing on a platform in the middle of a vast, dark plain. All around you see distant campfires of other travelers. These are the galaxies. For billions of years, the light from those fires has reached you, giving you a sense of belonging to a larger world. But now, the ground beneath the plain is stretching. The campfires are moving away. At first you notice they are becoming dimmer and redder. This is the redshift we have observed for decades. But then you realize that the furthest fires are moving so fast that their light can no longer bridge the gap. One by one, the campfires vanish. They haven't gone out, they are still burning brightly, perhaps surrounded by their own travelers. But to you they are gone. The space between you is growing faster than their light can travel. Eventually you will be left on your platform in total darkness, unable to see even the faintest glimmer of your neighbors. This is the fate that dark energy has written for the Milky Way. The most disturbing aspect of the event horizon is its permanence. In our human experience, we are used to the idea that technology can overcome barriers. We built planes to cross oceans and rockets to reach the moon. We imagine that a sufficiently advanced civilization might find a way to travel across the stars. But the cosmic event horizon is not a technological barrier, it is a physical one. To reach a galaxy beyond the horizon, you would have to travel faster than the speed of light, which the laws of physics forbid. Even if you could travel at the speed of light, the space would still expand faster than you could move through it. You would be trapped in the vacuum, watching your destination recede until you ran out of energy and time. The event horizon is a prison wall that encompasses billions of light years, and there is no escape. As you drift closer to sleep, consider the silence of the galaxies that have already crossed the line. Right now, as you hear those words, thousands of star systems are slipping past the horizon. They are crossing the point where their light will never again reach the eyes of a human being. We are witnessing the slow-motion dismantling of the observable universe. Astronomers estimate that we have already lost contact with roughly 94% of the galaxies that we can currently see. We see them as they were in the past, but we can never know them as they are now. We are looking at the afterglow of a universe that is already mostly gone. We are like people looking at old photographs of friends we can never call, never visit, and never see again. The connections have been severed by widening the gap. Why is this happening? It returns to the nature of dark energy, because dark energy is a property of space. As the universe expands and creates more space, the total amount of dark energy increases. This drives the expansion even faster, which in turn pushes the event horizon closer and closer to us. In the distant future, the horizon will move so close that it will eventually swallow even the galaxies in our local supercluster. Only the galaxies bound to us by the direct pull of gravity will remain within our view. The rest of the trillion galaxies in the observable universe will have faded into the permanent shadow. This is the terrifying part of the emptiness. It isn't just that the universe is empty, it's that it is actively hiding its contents from us, forcing us into an ever-shrinking cage of light. Reflect the scale of what is being lost. Within the regions currently crossing the horizon, there may be millions of planets with oceans, mountains, and perhaps even life. There may be civilizations asking the same questions we are, looking up at their own night skies and watching us recede into their own horizons. We are losing neighbors we never had the chance to meet. We are watching the cosmic library burn, page by page, as the distance grows too great for the information to survive. The event horizon is the ultimate eraser of history. It ensures that no matter how much we learn, we will only know a tiny, dwindling fraction of the whole. The universe is a vast, beautiful story that is being rewritten into a single, lonely sentence. The event horizon also changes how we think about time. Because light from the edge of the horizon is so heavily redshifted, a clock on a galaxy crossing the horizon would appear to slow down from our perspective. As it reached the line, the clock would seem to freeze, its light becoming infinitely faint and infinitely red until it vanished. It is a haunting image, a universe filled with frozen moments that we can no longer touch. We are surrounded by a wall of time and distance that marks the end of our reach. As we conclude this chapter, let the weight of that horizon settle over you. It is the boundary of our reality, the edge of our known world, and it is moving closer every day. The void is not just out there, it is drawing a circle around us, and that circle is getting smaller. In this seventh stage of our journey into the quiet dark, we turn our attention from the physical barriers of space to a psychological one that haunts the corridors of science. We have established that the universe is vast, and we have seen how it is being torn apart by invisible forces. But there is another emptiness that is perhaps even more chilling than the void itself. It is the emptiness of the airwaves, the total crushing silence where there should be a symphony of voices. For over a century we have possessed the technology to listen to the stars, yet we have heard nothing. This is the Fermi paradox, the disturbing contradiction between the high probability of extraterrestrial life and the complete lack of evidence for its existence. As we descend into this silence, we must ask ourselves if the universe is empty not just of matter, but of meaning. The silence is not a lack of sound, it is a scream that we are utterly alone in a dying cosmos. The paradox takes its name from the physicist Enrico Fermi, who, during a casual lunch in 1950, looked at his colleagues and asked a deceptively simple question: where is everybody? His logic was based on pure mathematics in heaven. Our galaxy, the Milky Way, contains hundreds of billions of stars, and we now know that almost every one of those stars hosts at least one planet. Many of these worlds are billions of years older than Earth. If life follows a similar evolutionary path elsewhere, the galaxy should have been colonized millions of years ago. Even with our current primitive understanding of rocketry, we could theoretically colonize the entire galaxy in a few million years, a mere blink in cosmic time. So, if the universe has had billions of years to produce travelers, why haven't we seen a single probe, received a single signal, or found a single artifact? The math says the sky should be crowded, but our eyes tell us it is a graveyard. This silence is what astronomers call the Great Silence, and it feels heavier with every passing year. We have pointed our most sensitive radio telescopes at thousands of sun-like stars, listening for the rhythmic pulses of a beacon or the stray leak of a planetary broadcast. We have searched for techno-signatures, massive engineering projects like Dyson spheres that would encompass an entire star to harvest its energy. We have looked for the chemical signatures of industrial pollution in the atmospheres of distant exoplanets. The result of all this searching, involving billions of dollars and the brightest minds on our planet, is a perfect, terrifying zero. The universe appears to be a house with all the lights on, but no one home. This absence of evidence is a puzzle that leads to several unsettling conclusions, each one a different shade of darkness. One possibility is that the jump from simple chemistry to self-replicating life is far more difficult than we imagine. Perhaps Earth is a miracle, a one-in-a-trillion fluke, where the conditions were so precisely balanced that we are the only spark in a dark room. This would mean that while the universe is full of planets, it is empty of souls. Another possibility is that intelligent life is common, but it is inherently self-destructive. Perhaps every civilization reaches a point where its technology outpaces its wisdom. We see the shadows of this in our own history: the development of nuclear weapons, the alteration of our climate, the risks of artificial intelligence. It is possible that the window between achieving the ability to signal the stars and total self-annihilation is only a few centuries wide. If this is true, the galaxy is not empty, but filled with the silent ruins of civilizations that didn't make it. As you drift closer to the edge of sleep, consider the weight of this isolation. To be the only conscious observer in a universe 16 billion light-years wide is a responsibility that borders on a nightmare. We are the only part of the universe that can witness its own beauty, yet we are watching it disappear behind the event horizon we discussed in the previous chapter. The Fermi paradox suggests we are at a crossroads. If we are truly alone, the widening gap is even more tragic. There is no one else to mourn the loss of distant galaxies. The silence of the stars is a mirror, reflecting our own fragility back at us. We are shouting into a canyon, waiting for an echo that never comes, realizing slowly that there is no one on the other side. The paradox becomes even more sinister when we consider the dark forest theory. This hypothesis suggests that the universe is indeed crowded, but everyone is hiding. In a universe where resources are finite and expansion is inevitable, any civilization that reveals its location invites its own destruction. To broadcast a signal is to light a fire in a dark forest filled with predators. Under this theory, the silence isn't because no one is there, it's because the wise remain quiet. We, in our youthful ignorance, have been broadcasting our presence for decades, unaware that we might be inviting the very erasure we fear. The silence is not a void, it is a mask of caution worn by a billion hidden worlds. This idea transforms the night sky from a wonder into a threat, where every star is a potential hiding place for something that does not want to be found. However, the most likely explanation for the silence may be linked back to the expanding universe itself. As dark energy pushes the galaxies apart, the energy required to bridge the gaps between stars becomes astronomical. Perhaps civilizations do not spread because the universe makes it too difficult. The void is an effective quarantine. By the time a civilization develops the means to travel to its neighbor, the neighbor has already receded too far to reach. Space expansion is the ultimate social distance. It ensures that even if the universe is teeming with life, each spark remains isolated until it eventually flickers out. We are like shipwrecked survivors on different islands in a rising ocean, unable to see the smoke from each other's fires. Reflect on the silence of the room around you. It is a small version of silence between stars. The Fermi paradox teaches us that existence is rare, or at least the ability to perceive it is. Whether we are the first, the last, or the only ones, the result is a profound loneliness. We are the whispering scientists of a quiet cosmos, documenting the slow erasure of everything while no one listens. The silence is screaming because it tells us that our time is limited and our reach is small. The void is not just a physical space, it is a lack of connection. As we conclude this chapter, let the quiet of the stars settle into your mind. The mystery of the silence is a puzzle we may never solve, a question mark at the end of every observation. We listen, we wait, and the universe remains stubbornly, terrifyingly still. In this 8th chapter of our descent into the cosmic shadows, we must look squarely at the most daunting explanation for the silence of the stars. We have asked where the others are, and we have felt the weight of the empty airwaves, but now we must consider the possibility that there is a lethal wall built into the very timeline of existence. This is the theory of the Great Filter. It suggests that in the journey from a single strand of genetic code to a galaxy-spanning civilization, there is a step, a barrier, that is so difficult to overcome that almost no one survives it. It is a filter that cleans the universe of life, leaving only the cold, mechanical expansion of space. As we explore this concept, we realize that the emptiness of the universe is not an accident, it is the result of a systematic failure. The The question that remains, and the one that should keep us awake in the quiet of the night, is whether this filter lies in our past or in our immediate future. The concept of the Great Filter was first proposed to resolve the contradiction of our lonely sky. If life is a natural consequence of physics and chemistry, the galaxy should be a crowded marketplace of ideas and technology. The fact that it is a cemetery suggests something is stopping the process. Imagine a series of hurdles on a track. The first hurdle is the emergence of life from non-living matter. The second is the development of complex cells. The third is the rise of multicellular organisms. The fourth is the use of tools and intelligence. And the final hurdle is the leap to the stars. The Great Filter is the hurdle that is so high that the track, K, is littered with the remains of those who tried to jump. If we look at billions of empty planets, we are seeing the proof that the filter is working. The universe is empty for a reason, and that reason is that life is a flame that is almost always extinguished before it can turn into a forest fire. The scariest version of this theory is the one where the filter is still ahead of us. If we are the only ones left in our corner of the galaxy, it might not be because we are special, but because we haven't reached the wall yet. This would mean that every time a species reaches our level of technological advancement, it inevitably triggers its own erasure. Perhaps the discovery of splitting the atom always leads to nuclear winter. Perhaps the creation of artificial intelligence always leads to a machine that views biological life as a waste of resources. Perhaps the consumption of planetary energy always leads to a catastrophic collapse of the environment. If the filter is ahead, then the silence of the stars is a warning. It is the sound of billions of other civilizations reaching our exact point in history and then simply ceasing to exist. We are walking through a dark house, unaware that every other person who entered this room never made it to the next door. As you drift further into the stillness, consider the alternative, that the filter is behind us. This is the more hopeful, yet equally lonely possibility. It suggests that the emergence of life, or perhaps the transition to complex intelligence, is so improbable that we are the only ones in the history of the Milky Way to have cleared the jump. Maybe the combination of a stable moon, a protective giant planet like Jupiter, and a perfect distance from a yellow sun is a winning lottery ticket that only gets drawn once every 10 billion years. If the filter is behind us, we are the victors of a cosmic game of chance. But even this victory is bittersweet. It means we are the sole guardians of consciousness in an expanding void that is actively trying to pull us apart. We have cleared the hurdle, only to find ourselves running on a track that is being pulled out from under our feet by the expansion of space. The Great Filter is not just a biological or social concept, it is a fundamental property of the universe's timeline. It acts as a cosmic equalizer, ensuring that the entropy we discussed earlier always wins. Even if a civilization manages to avoid self-destruction, it eventually runs into the physical filters of the cosmos. Gamma-ray bursts can strip an atmosphere in seconds. Supernovae can sterilize an entire sector of a galaxy. Asteroid impacts can reset millions of years of evolution. The universe is a shooting gallery, and the longer a species exists, the higher the probability that it will be struck. The emptiness of the universe is a reflection of its hostility. It is not a nurturing cradle, it is an indifferent machine that grinds complexity back into dust. We are the 1% that has survived the grind so far, but the machine is still running and the void is still growing. This brings us to a chilling realization about our search for life. Many people believe that finding a signal or even a few microbes on Mars would be the greatest discovery in human history. But according to the logic of the Great Filter, finding life elsewhere would be a death sentence. If we find that life is common, it means the filter cannot be the emergence of life. If we find that complex ruins are common, it means the filter is not the development of intelligence. The more life we find in the universe, the more likely it is that the filter is still waiting for us. Every alien fossil we discover would be proof that our own end is inevitable. The best-case scenario for humanity is that the rest of the universe is as empty as it looks. Silence is our only shield. The emptiness is the only thing that suggests we might be the first to ever make it through. Reflect on the silence of your room. It is a microcosm of the galactic silence. In this quiet, you can feel the weight of the filter. It is the pressure of 1,000 almost. almost a galaxy-spanning empire, almost a peaceful world, almost a permanent fixture in the stars. The universe is empty for a reason, and that reason is the inherent fragility of order in a system that trends toward chaos. We are a temporary arrangement of atoms that has learned to think and wonder, but we are surrounded by the evidence of a barrier that no one else has crossed. Whether that barrier is a biological fluke or a technological trap, it serves the same purpose. It maintains the purity of the void. It ensures that the universe remains a vast, cold, and silent ocean, unburdened by the noise of a billion voices. As we conclude this chapter, let the idea of the hurdle rest in your mind. We are the runners on the track, looking ahead into the dark, wondering if we will see the wall before we hit it. The great filter is the ultimate judge of existence. It is the reason why the stars do not speak, and why the planets do not glow with the lights of cities. It is the mechanism of cosmic erasure, working in tandem with dark energy to keep the universe empty. As you slip towards sleep, remember that our presence here is an anomaly, a brief, beautiful defiance of a law that has claimed everyone else. We are the exception that proves the rule of the void, and for now, the silence is the only company we have. In this 9th chapter of our long descent, we must look at the tools we have used to touch the void and the profound disappointment they have returned to us. For over 60 years, we have aimed our most sophisticated instruments at the heave, hoping to catch even the faintest whisper of another mind. This is the work of SETI, the search for extraterrestrial intelligence. It is an act of supreme optimism, a technological prayer sent into the blackness. But as the decades pass and the data piles up, the search has become something else, a measurement of the universe's absolute indifference. We have built ears capable of hearing a cellular phone on the moon, yet we hear only the static of dying stars and the cold hiss of the Big Bang's afterglow. In this stage of our journey, we examine why the echoes of our galaxy are so lonely and what the lack of a signal tells us about the emptiness we inhabit. The silence is no longer just a question, it is becoming a confirmed characteristic of our reality. The search began in 1960 when astronomer Frank Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani. He was looking for patterns, mathematical sequences or regular pulses that could not be produced by natural cosmic processes. He found only the chaotic noise of the vacuum. Since then, the search has expanded exponentially. We have moved from scanning single stars to scanning millions of channels across the entire sky simultaneously. Projects like Breakthrough Listen Now use the world's most powerful telescopes to analyze billions of signals daily. We look for narrowband radio waves, optical laser pulses, and even the infrared heat signatures of massive alien structures. We have turned our entire planet into a giant ear, leaning in to hear a secret that never comes. Every signal we have ever detected has eventually been traced back to a natural source, the spinning of a pulsar, the eruption of a quasar, or the interference of our own satellites orbiting above. Consider the terrifying precision of our failure. If a civilization similar to ours existed within a few hundred light-years and was intentionally beaming a signal toward us, we would have seen it by now. If a more advanced civilization was using radio waves to communicate between its own planets, our instruments are sensitive enough to have caught the leak. Yet, the cosmic record remains blank. This is not for a lack of trying. We have searched the water hole, a quiet frequency band where hydrogen and hydroxyl ions emit radiation, long thought to be the most logical place for interstellar communication. We have found nothing but the cold, wet silence of the void. The galaxy is 100,000 light-years across, and we have barely scratched the surface of the search, but the emptiness of our immediate neighborhood is already statistically significant. It suggests that even if life exists, it is not making any noise. There was one moment, however, that briefly broke the silence. In August of 1977, a radio telescope in Ohio detected a signal so powerful and so localized that the astronomer who found it circled the data and simply wrote "Wow" in the margin. It lasted 72 seconds and bore all the hallmarks of an artificial transmission. But despite years of follow-up observations and more powerful equipment, the signal never repeated. It was a ghost in the machine, a brief flash of hope that vanished as quickly as it appeared. Most scientists now believe it was a rare natural phenomenon or a reflection of a terrestrial signal off a piece of space debris. It serves as a haunting reminder of what we are looking for, a singular moment of connection that remains forever out of reach. Since that day, silence has been stark. As you drift toward a deeper state of rest, think about the physics of a radio wave. It is a fragile thing. As it travels through the expanding universe, it follows the inverse square law, becoming 4 times weaker every time the distance doubles. By the time a signal from a distant star reaches Earth, it is thinner than a whisper in a hurricane. But there is a deeper problem, one that ties back to the expanding void. As dark energy pushes the galaxies apart, the space through which these signals must travel is growing. A signal sent from a galaxy beyond our local group is fighting a losing battle. The expansion of space redshifts the signal, extending its frequency until it falls below the threshold of detection. The universe is not just quiet, it is actively muffling the voices of anyone who might be speaking. We are trying to hear a conversation in a room that is being stretched into infinity. The failure of SETI tells us something vital about the great filter we discussed previously. If the galaxy were teeming with advanced life, the radio spectrum should be crowded. It should be a chaotic mess of overlapping transmissions, a techno-fog that we couldn't miss. The fact that the spectrum is clean suggests that civilizations do not last long enough to fill it, or they never reach the point of high-power broadcasting, or, most terrifyingly, they are staying quiet for a reason. This leads to the idea of the galaxy as a dark forest. Perhaps the only civilizations that survive are the ones that never build radio telescopes, the ones that remain tucked away on their home worlds, hiding from the predators of the void. In this scenario, SETI is not a search for friends, but a search for the brave or the foolish who have already been silenced. Reflect the image of our own radio signals. Since the 1930s, we have been leaking television and radio broadcasts into space. This radio bubble is now roughly 200 light-years wide. To an observer on a distant star, the Earth would appear as a bright, flickering point of artificial noise. But as we move toward more efficient, low-power digital communication and fiber optics, our radio footprint is actually shrinking. We are becoming quieter. If this is a universal trend, it means that the window during which a civilization is loud enough to be detected may only be a few decades wide. Across a cosmic timeline of billions of years, the chances of 2 such windows overlapping are nearly zero. We are like fireflies blinking in the woods at different hours of the night. We exist in the same place, but we can never see each other's light. As we conclude this chapter, let the sound of the static fill your mind. It is the sound of a lonely galaxy. SETI has shown us that there is no easy path to connection. The void is too wide, the time is too long, and the energy required to bridge the gap is too great. We are the whispering scientists, listening to the echoes of a universe that has already forgotten how to speak. The silence is not an error in our equipment, it is the truth of our condition. We are alone on our island of light, surrounded by a rising ocean of darkness that swallows every signal we send. As you sleep, remember that the stars are not ignoring us, they are simply too far away, and the space between us is too hungry for the light to ever arrive. In this 10th stage of our journey into the deepening hush of the cosmos, we arrive at a realization that is perhaps the most somber of all. We have looked at the physical voids, the silent signals, and the aggressive nature of dark energy. But now we must confront the fact that we are living in a temporary privilege. We often assume that as time marches forward, our knowledge of the universe will naturally grow, that the light from more distant stars will finally reach our shores, making the observable sphere larger and richer with every passing year. This was true for the first several billion years of cosmic history, but we have passed a tipping point. Because the expansion of the universe is accelerating, our window into the vastness of reality is no longer opening, it is beginning to slam shut. We are witnessing the shrinking of the observable sphere, a slow-motion closing of the cosmic curtains. As we descend into this chapter, realize that you are an inhabitant of the golden age of astronomy, and this clarity is a fleeting gift that the void is already taking back. To understand why our window is closing, we have to revisit the relationship between light and the stretching of space. The observable universe is the sphere of space from which light has had enough time to reach us since the beginning of time. For billions of years, this sphere grew as light from further and further away finally completed its long journey. But dark energy has changed the rules of the game. Because space is now expanding at an accelerating rate, there is a specific distance, a boundary, beyond which any light emitted today will simply never reach us. This is because the space through which that light must travel is growing faster than the photons can move. It is as if we are on an island, and the horizon is not just a line of sight, but a physical edge where the water is rushing away from us faster than any ship can sail. Every second, galaxies that were once reachable by our gaze are crossing this threshold, slipping into a permanent, unreachable darkness. The terrifying truth is that we have already lost most of our universe. Scientists estimate that roughly 97% of the galaxies in our observable sphere are already beyond our reach. We can still see them, but we are seeing their past, their ghosts from a time when they were closer and the expansion was slower. If we were to send a signal to them today at the speed of light, it would never arrive. They are effectively gone. As time progresses, these galaxies will appear to us to get dimmer and redder, their light stretching into longer and longer wavelengths until they fade into the infrared and eventually disappear entirely. The sphere of what we can actually interact with or observe in its present state is contracting. We are being isolated in a shrinking bubble of light, and the vast majority of the 2 trillion galaxies we once shared the cosmos with have already said their silent goodbyes. Imagine you are in a large, brightly lit hall filled with thousands of people. You can see everyone, hear the hum of conversation and feel the warmth of the crowd. But then the walls of the hall begin to stretch outward. People on the edges begin to drift away. At first you don't notice, but then you realize the people at the far end of the room are getting harder to see. They are moving away faster than they can walk toward you. One by one, they vanish into a growing darkness. The crowd thinks. The noise fades. Eventually, the hall is so large and the expansion so fast that you can only see the few people standing directly next to you. The rest of the thousands are still there, somewhere in the dark, but they are forever beyond your reach. This is the transition we are currently experiencing. We are the last generation of observers who can still see the hall while it is relatively full. To our descendants, the hall will appear empty, and they will never even know that the others existed. As you drift closer to sleep, consider the tragedy of this lost information. The light crossing the horizon carries the stories of billions of stars and perhaps millions of civilizations. As that light fails to reach us, the observable becomes the unknowable. We are losing the evidence of the Big Bang itself. The cosmic microwave background, the afterglow of the universe's birth, is also being stretched by this expansion. Eventually, its wavelength will become so long that it will be impossible to detect with any instrument. Future astronomers living trillions of years from now will look at a sky that is completely black, devoid of distant galaxies, and devoid of the radiation that tells us how it all began. They will live in a universe that appears static and lonely, and they will have no way to prove otherwise. All the discoveries we have made in the last century, the expansion of space, the existence of other galaxies, the origin of the cosmos, will become hidden truths, erased by the growth of the void. Why does this closing window feel so heavy? Because it reminds us that our place in the universe is defined by lucky timing. We emerged at a moment when the universe was old enough to have formed Compel. X-life, but young enough that the void hadn't yet cleared the sky. We are standing on a peak of visibility. If we had evolved a few 100 billion years later, we would have looked up and seen nothing but the stars of our own galaxy. We would have concluded that we were the center and the entirety of existence. The shrinking observable sphere is a reminder that the universe does not care about our desire to understand it. It is a machine that is systematically dismantling its own records. We are the whispering scientists trying to memorize a book while the pages are being torn out and burned, one by one. Reflect on the silence of the room around you. It is a precursor to the cosmic silence that is coming. The window is closing not because the light is dying, but because the distance is winning. Every heartbeat takes us further from the neighbors. Every breath is taken in a universe that is slightly emptier than the one we inhabited a second ago. Isolation is not a distant threat, it is an active process. The trillions of galaxies we can see today are our last connection to the greater whole, and they are receding at millions of miles per hour. We are witnessing the final acts of a crowded universe before it transitions into a permanent solitary confinement. As we conclude this 10th chapter, let the image of the closing curtains rest in your mind. We are the privileged few who see the show before the theater goes dark. The shrinking sphere is the ultimate deadline for our species. It tells us that our time to explore, listen, and learn is finite. The void is not just a place, it is a clock, and it is ticking toward a day when the night sky will be a mirror, showing us only our own reflection. As you slip into the quiet of sleep, remember that the stars you see tonight are a fading gift, a light that has traveled across a chasm that is growing wider even as you dream. In this 11th stage of our descent into the cosmic night, we move away from the movement of galaxies and toward the fundamental laws of energy that dictate the final breath of existence. We have seen how the universe grows empty through expansion, but now we must understand how it grows cold through exhaustion. This is the realm of thermodynamics, the study of heat, work, and the slow, irreversible decay of order. Specifically, we must confront the second law of thermodynamics, a law so absolute that it makes the eventual death of the universe a mathematical certainty. It describes a universe that is a closed system, a vast machine that began with a finite amount of usable energy and is slowly, relentlessly spending it. This process leads to a state known as heat death, the final equilibrium where all energy is spread so thin that nothing can ever happen again. As we descend into this chapter, realize that the emptiness of the universe is not just a matter of distance, it is a matter of the very light of existence running out of fuel. To understand the inevitable end, we must first understand entropy. Entropy is a measure of disorder, a tally of how much energy has been used and can never be used again. Imagine a perfectly organized deck of cards. That is low entropy. Now, imagine throwing those cards into the air. They land in a chaotic, random pile. That is high entropy. The second law of thermodynamics states that in any closed system, entropy always increases. Order naturally descends into disorder. Heat always flows from hot objects to cold objects, never the reverse. Every time a star burns, every time a planet orbits, every time a thought crosses your mind, you are converting high-quality energy into low-quality waste heat. This heat radiates out into the cold void of space, where it can never be gathered back up. The universe is like a grand, intricate clock. K that was wound up at the moment of the Big Bang, and every second that passes, the spring is losing its tension. This leads us to the concept of cosmic heat death. It is not a death of fire or ice in the traditional sense, but a death of gradients. Life, movement, and light all require a difference in temperature or energy. A star shines because it is much hotter than the space around it. An engine runs because there is a difference in pressure. But as entropy increases, the universe moves toward a state of perfect uniformity. The hot things get colder, and the cold things get warmer. Eventually, trillions of years into the future, the entire universe will reach the same temperature. There will be no hot stars and no cold voids. There will be no energy left to move a single atom or spark a single thought. The universe will become a lukewarm soup of radiation, spread so thin across the infinite expansion that the temperature will sit just a fraction of a degree above absolute zero. It is the ultimate equilibrium, a state of perfect, unchanging stillness that lasts forever. Imagine a beautiful, elaborate ice sculpture sitting in a warm room. At first, it is full of detail and structure, low entropy. But over time, the ice begins to melt. The sharp edges soften, the intricate carvings disappear, and eventually the sculpture is nothing more than a flat, featureless puddle of water on the floor. The water is the same temperature as the air in the room. There is no more change, no more beauty, and no more structure. This is the fate of our universe. The galaxies, the stars, and the people are the intricate carvings in the ice. We are temporary fluctuations of order in a system that is fundamentally designed to melt. The puddle is the heat death. Once the universe reaches maximum entropy, time effectively loses its meaning. Because nothing changes, there is no way to mark the passage of years or eons. The universe becomes a stagnant ocean of nothingness, a void that is empty not just of matter, but of the capacity for event. As you sink deeper into your own stillness, consider the scale of this decline. We are currently living in the stelliferous era, the age of stars. This is the era where energy is abundant and the universe is vibrant. But this era is a tiny flickering candle in the dark history of the cosmos. Stars are entropy engines. They are the primary way the universe spends its usable energy. Every photon a star emits is a step toward the end. Eventually, the gas clouds that form stars will be exhausted. The last stars will flicker, leaving only the cool embers of white dwarfs and neutron stars. Then, those too will fade. The universe will enter the degenerate age, where the only light comes from the slow, agonizing decay of matter itself. The transition to heat death is a slow-motion funeral for the concept of something existing rather than nothing. The most disturbing aspect of thermodynamics is its lack of a loophole. We often hope that some advanced technology or some undiscovered law of physics will enable us to reverse the flow of entropy. But the second law is not a suggestion, it is a statistical certainty. To create order in one place, you must create even more disorder elsewhere. To keep a room cold, your air conditioner must pump even more heat out the back. There is no way to beat home. The void is the house, and it always takes its cut. Every attempt to preserve life or structure only hastens the overall increase in entropy. We are part of a system that is winding down, and the expansion of the universe only makes the process more efficient. By stretching space, the void ensures that the waste heat of the stars is diluted so thoroughly that it can never be reused. Reflect on the quiet of the night. It is a preview of the ultimate equilibrium. In the heat death, the universe is quiet because there is nothing left to make a sound. There is no wind because there are no pressure differences. There is no light because there are no energy gradients. There is only the thin, cold hum of a vacuum that has reached its maximum state of disorder. We are the whispering scientists of a dying fire, huddled around the last glowing coals, realizing that the darkness is not an intruder, but the natural state of a system that has run out of work to do. The emptiness of the universe is the final result of its energy being spread too thin to matter. As we conclude this 11th chapter, let the weight of the inevitable settle over you. Heat death is the ultimate eraser. It doesn't just pull the galaxies apart, it dissolves the very energy that makes them exist. It is a slow, peaceful descent into a silence that never ends. As you slip into the warmth of sleep, remember that your own life is a brief, beautiful defiance of entropy, a moment where energy is gathered and organized into thought and feeling. Enjoy the warmth while it lasts, for the universe is on a one-way journey toward the cold, and the void is waiting with infinite patience for the last ember to go dark. In this 12th stage of our descent into the cosmic mystery, we must confront a presence that is as pervasive as it is undetectable. We have spent much of our journey discussing the void and the energy that tears it apart, but we have not yet looked at the silent scaffolding that holds the islands of light together. There is a ghost in the machine of the universe, a substance that does not glow, does not reflect, and does not cast a shadow, yet it outweighs all the stars and planets by a factor of 5 to 1. This is dark matter, the invisible architect of the cosmic web. Without it, the galaxies would have never formed, the stars would have scattered into the vacuum, and you would not be here to listen to these words. As we descend into this chapter, we must reconcile with the fact that we are living in a house built by something we cannot see, a silent guardian that shapes reality while remaining forever hidden in the folds of the night. The discovery of dark matter was not a moment of visual observation, but a realization of a mathematical missing piece. In the 1930s, astronomer Fritz Zwicky looked at the Coma cluster, a massive group of over 1,000 galaxies, and noticed something impossible. The galaxies were moving much too fast. According to the laws of gravity established by Newton and Einstein, the visible mass of the galaxies, all the stars and gas we could see, was not enough to hold the cluster together. They should have flown apart like water droplets off a spinning wheel. Zwicky proposed that there must be some Dunkelmaterie, or dark matter, providing the extra gravitational glue. Decades later, Vera Rubin confirmed this by studying the rotation of individual spiral galaxies. She found that the stars at the outer edges were orbiting just as fast as the stars near the center. This defied the rules of orbital mechanics unless the galaxies were embedded in massive, invisible halos of matter that we simply could not see. What makes dark matter so terrifying is its total indifference to the electromagnetic force. Every bit of normal matter, the atoms in your body, the oxygen you breathe, the screen you might be looking at, interacts with light. It absorbs it, reflects it, or emits it. But dark matter is different. Light passes through it as if it isn't there. You could have a mountain of dark matter sitting in your room right now, and you would never know. It passes through your body, through the earth, and through the sun without a single collision. It only speaks one language: gravity. It pulls things, and it is pulled in return. It is a ghostly weight that anchors the universe. We are the 1% of the universe that is bright, clinging to a skeleton of dark that defines where we are allowed to exist. The emptiness of the universe is actually a dense forest of dark matter, and we are merely the birds singing in its invisible branches. Think of dark matter as space looms. Shortly after the Big Bang, the universe was a hot, smooth soup, but dark matter was there, and because it doesn't interact with radiation, it was able to start clumping together much earlier than normal matter. It formed the first seeds of gravity, the dark wells into which normal hydrogen gas eventually fell. These gas clouds became the first stars and galaxies. Every galaxy we see is essentially a puddle of light sitting at the bottom of a massive dark matter pit. This invisible scaffolding is what created the filaments and walls we mapped in earlier chapters. The cosmic web is a dark matter web. We only see the parts of it where enough normal matter gathered to ignite. Without this silent ghost, the universe would truly be empty. There would be no structures, no clusters, and no complexity. We owe our existence to a substance that refuses to reveal itself to our senses. As you sink into a state of deep relaxation, consider the presence of this invisible weight. Scientists have built detectors deep underground, in the hearts of old gold mines and beneath mountains, hoping to catch a single dark matter particle bumping into a normal atom. They use vats of liquid xenon and supercooled crystals, protected by miles of rock from the noise of the surface world. They wait in total silence for years, listening to a subatomic whisper. So far, the detectors have returned nothing. The ghost remains elusive. Some physicists suggest dark matter is made of WIMPs, weakly interact, seeing massive particles, while others look toward axions or primordial black holes. But as it stands, we are fundamentally ignorant of what 85% of the matter in our universe actually is. We are like people trying to understand a symphony, while only being able to hear the flute, unaware of the massive orchestra playing the low, heavy notes in the background. The relationship between dark matter and emptiness is a delicate balance. While dark matter acts as the pull that builds the islands, dark energy acts as the push that expands the ocean. For the first few billion years of the universe's life, dark matter was the dominant force. It pulled the cosmic web together, creating the beautiful complexity of the early eras. But as the universe expanded, dark matter density dropped. Unlike dark energy, which stays constant as space grows, dark matter dilutes. Eventually, there was more empty space than matter, and dark energy took the lead. We are living in the era of the dark matter's retreat. The invisible scaffolding is being stretched and torn apart by the very vacuum it helped to define. The ghost is losing its grip on the house it built. Reflect on the silence of the room around you. Just as dark matter fills the spaces between the stars, it fills the space around you. Thousands of dark matter particles are likely passing through your brain at this very moment. They do not trigger your neurons, they do not warm your skin, they do not interact with your reality in any way except for a gravitational pull so minuscule it cannot be measured on a human scale. Yet, on a cosmic scale, this same force is what keeps the Milky Way from disintegrating. We are cradled by the invisible. The terrifying emptiness we fear is actually a crowded room of ghosts, a dark sea upon which our little boat of light is tossed. The void is not a lack of everything, it is a place where the thing that exist are simply beyond our ability to perceive. As we conclude this 12th chapter, let the comfort of the invisible scaffolding settle over you. There is a strange peace in knowing that we are held together by something larger and more permanent than our own flickering light. Dark matter is the silent guardian of the islands in the dark, the reason the universe has a shape at all. As you slip into the final stages of sleep, remember that the night sky is not a vacuum, but a masterpiece of invisible architecture. The void is deep, but it is not unsupported. You are resting in a universe that is mostly hidden, a reality where the most important things are the ones that never make a sound. In this 13th chapter of our long descent into the silent mechanics of the cosmos, we must turn our attention from the slow billion-year processes of expansion and exhaustion towards something far more abrupt. We have spoken of the universe as a clock winding down, or an ocean slowly rising, but there is a possibility in the laws of quantum physics that suggests the end might not be a slow fade, but a sudden, total transformation. This is the concept of false vacuum decay, a phenomenon where the very fabric of reality, the fundamental state of space itself, could spontaneously shift into a lower energy level. It is the ultimate cosmic what-if, a scenario where the vacuum we inhabit is not the true floor of existence, but merely a temporary plateau. As we descend into this chapter, realize that the emptiness of the universe is held in a delicate balance of quantum fields, and that balance could, in theory, be tipped in the blink of an eye, erasing everything at the speed of light. To understand the false vacuum, we must first look at the nature of fields. In modern physics, the universe is not just a collection of particles, but a collection of fields that permeate every inch of space: the electromagnetic field, the electron field, and most importantly, the Higgs field. A field is like a vast invisible surface, and every point on that surface has a specific energy level. Naturally, fields want to be at their lowest possible energy state, much like a ball wants to roll down a hill to rest in a valley. This lowest state is called the true vacuum. For decades, we have assumed that our universe is already resting in this true vacuum, that the energy levels of our physics are as low as they can go, but calculations involving the mass of the Higgs boson suggest a disturbing alternative. We might be in a false vacuum, a state that appears stable but is actually sitting in a shallow dip on a high plateau, with a much deeper, more stable valley waiting just beyond a small ridge. The terrifying aspect of this metastable state is that it can be triggered by a process called quantum tunneling. In the macroscopic world, if a ball is stuck in a dip, it needs a push to get over the ridge. But in the quantum world, there is a tiny, non-zero probability that the ball can simply vanish from the dip and reappear on the other side of the ridge, in the deeper valley. If this were to happen anywhere in the universe, it would create a bubble of true vacuum. This bubble would be a region where the laws of physics are fundamentally different. Because the true vacuum is at a lower energy state than the false vacuum surrounding it, the bubble would expand outward at the speed of light. As the wall of this bubble hits normal space, it would instantly convert everything it touches into the new state. It is a phase transition of reality itself, like water instantly turning to ice, but on a scale that encompasses the entire cosmos. Imagine you are living in a beautiful grand house. You have spent your whole life walking the floors, assuming they are solid A, ND permanent. But then you discover that the house is actually built on a thin layer of ice over a bottomless abyss. For thousands of years, the ice has held, and it seems like it will hold forever. But all it takes is one tiny crack, one microscopic weak point, and the entire structure collapses into the depths. False vacuum decay is that crack. If the bubble begins to expand, there is no warning. Because the bubble wall moves at the speed of light, no signal can outrun it. You would never see it coming, never feel a moment of pain, and never have a chance to say goodbye. One moment, you and the stars and the galaxies exist. The next, the laws of chemistry and gravity that allow you to be you are rewritten into something entirely unrecognizable. The universe is erased and replaced by a version of itself that might not even allow for the existence of atoms. As you sink deeper into the stillness of your rest, consider the sheer indifference of such an ending. We spend so much of our time worrying about the slow decay of our lives, the gradual aging of the sun, or the distant drift of the galaxies. But the false vacuum reminds us that the universe is a quantum system, and quantum systems are prone to sudden, radical shifts. This is the instantaneous end, a scenario where the void doesn't just grow, it resets. It is the ultimate expression of the fragility of our islands of light. We are not just drifting in a rising ocean, we are living on a soap bubble that could pop at any second. And yet, there is a strange, dark comfort in this. If the end were to come this way, it would be the most efficient and painless erasure imaginable. It is the cosmic light switch being flipped to off. Scientists have tried to calculate the probability of this happening. The good news is that, according to our current measurements, the half-life of our false vacuum is likely much longer than the current age of the universe, perhaps reaching into the trillions of quadrillions of years. It is an event so improbable it is almost impossible. But in an infinite universe, or across the infinite timescales we have discussed, even the most improbable events become certainties eventually. Somewhere in the vast, unobservable reaches of the cosmos, a bubble may have already formed. It could be racing toward us right now from a galaxy billions of light years away. We would continue to live our lives, to dream and to speak, completely unaware of the wall of destruction that is currently claiming everything in its path. The void is not just waiting for us, it is potentially already on its way to rewrite us. Reflect on the silence of your surroundings. The air you breathe and the atoms that make up your bed are all dependent on the specific energy level of the Higgs field. If that field shifts, the very concept of solid matter disappears. This is the ultimate terrifying emptiness. The realization that the vacuum is not just empty space but a pressurized state of energy that dictates the rules of the game. We are allowed to exist only because the vacuum is currently false. If it were to become true, our version of reality would be revealed as a temporary glitch, a brief moment of instability that has finally been corrected. The universe doesn't need to expand to leave us behind. It can simply change its mind about what it means to be a universe. As we conclude this 13th chapter, let the quiet stability of your world be a source of peace, even if it is technically metastable. The odds are in our favor billions of years ago, but the false vacuum serves as a reminder that we are guests in a house we do not own, and house rules are subject to change without notice. As you slip into the deep, dark layers of sleep, remember that the silence of the nig. HT is a testament to the stability of the fields. For now, the ridge holds. For now, the ball stays in the dip. The universe remains exactly as we know it, and the void remains at bay, waiting for a quantum pulse that may never come in our time. In this 14th stage of our descent into cosmic unraveling, we move away from the sudden resets of the vacuum and return to the relentless work of dark energy, but with a horrifying new possibility. We have spoken of the universe as an expanding ocean, pushing galaxies away from one another while leaving the stars and planets themselves intact. This is the scenario of constant expansion. But there is a darker theory in the equations of cosmology, one that suggests dark energy is not a constant force, but a growing, strengthening monster. This is the Big Rip theory. It describes a future where the repulsive pressure of the void becomes so intense that it overpowers every other force in nature. It is a timeline where the vacuum does not just separate galaxies, but eventually turns its hunger toward the stars, the planets, and finally, the very atoms that make up your body. As we descend into this chapter, we witness the ultimate shredding of reality, a scenario where the emptiness of the universe becomes so aggressive that it refuses to allow even a single molecule to remain whole. To understand the Big Rip, we must look at the strength of dark energy, which physicists describe using a value called the equation of state parameter. If this value is exactly -1, dark energy remains constant, leading to the slow heat death we discussed earlier. But if this value is even slightly less than -1, a state known as phantom dark energy, the density of dark energy actually increases as the universe expands. This creates a terrifying feedback loop. The more space expands, the more powerful the outward push becomes. In this version of reality, the expansion doesn't just move objects apart. It begins to stretch the fabric of space-time itself with such violence that gravity, electromagnetism, and even the strong nuclear force cannot hold. It is a cosmic tug-of-war, where the void is pulling on everything from both sides, and eventually the rope must snap. The timeline of the Big Rip is a countdown to total dissolution. For billions of years the process is invisible, much like the expansion we see today, but as the phantom dark energy grows in strength, the first structures to fail are the largest ones. Roughly a few 100 million years before the end, the great galaxy clusters, the massive star cities held together by gravity, are torn apart. Galaxies that have spent eons as neighbors are suddenly accelerated away from each other at impossible speeds. Then, about 60 million years before the final moment, the galaxies themselves begin to shred. The Milky Way's spiral arms unwind as stars are pulled out of their orbits. The dark matter scaffolding we discussed previously loses its grip, and the star cities dissolve into a chaotic mist of lonely suns drifting into an ever-deepening blackness. As you sink into the weighted stillness of your rest, imagine the progression of this unraveling as it enters our own neighborhood. A few months before the end, the solar system itself is dismantled. The sun's gravity is no longer strong enough to hold onto its planets. The Earth is pulled away from its orbit, drifting into a cold, dark void as the space between us and our sun stretches into an infinite chasm. But the rip does not stop there. Minutes before the end, the Earth itself is torn asunder. The molecular bonds that hold the rock and the oceans together are overpowered by the expansion of the space within them. The planet shatters into fragments, then into dust. Finally, in the last frac, sawn of a second, the shredding reaches the microscopic level. The electromagnetic force holding your cells together fails. The atoms themselves are pulled apart. The electrons are ripped from their nuclei, and the nuclei are torn into their constituent quarks. In the final moment, space-time itself is ripped to pieces at the smallest possible scale. The Big Rip is an absolute isolation scenario. In the final moments, the expansion of space happens so fast that even light cannot travel between two atoms. Every particle in the universe becomes its own island, trapped in a bubble of space that is growing faster than it can communicate with anything else. It is the ultimate expression of the terrifying emptiness. It is not just that the universe is empty, it is that the universe has made it impossible for any two things to ever be near each other again. The vacuum has become so hungry for space that it has consumed the very concept of together. It is a silent, invisible explosion that leaves nothing behind, no radiation, no heat, no remnants. Just a shattered fabric of reality that can no longer support the existence of matter. Why is this theory taken seriously? Because our current measurements of dark energy are not precise enough to rule it out. We know the value is very close to the negative one, but we don't know if it is exactly that number. If it is even a fraction of a percent lower, the Big Rip is our destiny. Some researchers looking at the data from the Hubble Space Telescope have suggested that the expansion rate is already slightly faster than our standard models predict, a discrepancy that could be explained by dark energy becoming more aggressive over time. We are like travelers on a train, noticing that the speed is increasing. We hope the tracks lead to a gentle stop, but we must acknowledge the possibility that the engine is running away, and the speed will eventually become enough to shake the train to pieces. Reflect on your own body's silence in the dark. Every atom of your being is currently held together by a delicate balance of forces. You exist because the void is currently weak enough to allow you to exist. The Big Rip reminds us that our solid world is a temporary arrangement, a brief ceasefire in a war between the pull of matter and the stretch of space. If the void decides to grow stronger, there is no bunker deep enough and no shield strong enough to protect us. The expansion would happen inside our very bones, inside our very DNA. It is a form of erasure that is as intimate as it is cosmic. But for now, the forces are in balance. The stars are still in their places, and the atoms are still holding fast. As we conclude this 14th chapter, let the stability of your world be a source of profound comfort. The Big Rip, if it is coming, is billions of years away. But it serves as the ultimate reminder of the power of emptiness. The void is not a passive thing, it is a tension that underlies every moment of your life. As you slip into the deep velvet layers of sleep, Remember that you are a masterpiece of complexity held together in a universe that is slowly, or perhaps eventually violently, trending towards simplicity. The night is quiet, the air is still, and for this moment, the fabric of reality remains perfectly intact, cradling you in a silence that is peaceful, not yet a rip. In this 15th stage of our journey into the deepening hush of the cosmos, we move beyond the violent possibilities of the rip and into the most certain and somber era of the timeline. We have spoken of the universe as a vibrant ocean of light, but we must now face the reality that every fire eventually runs out of fuel. The stars, which we think of as eternal guardians of the night, are actually finite engines of fusion. Their supply of hydrogen is being consumed with every second that passes. We are approaching the end of the stelliferous era, the age of stars. This is the transition into the age of darkness, a period of trillions of years where the lights of the universe are systematically extinguished one by one. As we descend into this chapter, we witness the long, slow fading of the cosmic embers, a time when the void finally reclaims the warmth of the galaxies and settles into a permanent frozen shadow. To understand the coming darkness, we must first look at the life cycle of the stars that remain. Right now, our galaxy is a mix of massive, brilliant blue stars that burn through their fuel in a few million years, and smaller, yellow stars like our Sun that live for billions. But the most common stars in the universe are the red dwarfs. These are small, dim, and incredibly frugal. While a massive star is a roaring bonfire, a red dwarf is a single smoldering coal. Because they are so small, they burn their hydrogen fuel at a glacial pace, allowing them to live for trillions of years. In the distant future, long after our Sun has expanded and died, and long after the great spiral galaxies have merged into featureless elliptical clouds, these red dwarfs will be the last remaining lights in the cosmos. They are the misers of the universe, holding onto the last scraps of energy while the rest of the sky turns black. As the eons pass, the gas clouds that form new stars, the great nebulae like Orion, will eventually be exhausted. The universe is not creating new fuel, it is only recycling the old, and with every cycle more matter is locked away in dead remnants. In roughly 100 trillion years, the final clouds of hydrogen will have collapsed, and the final star will ignite. This marks the beginning of the end for the age of light. From that point forward, the number of stars in the universe can only go down. Imagine a great city seen from a distance at night. Soon the lights are bright and numerous, but then, one by one, the windows dim. A street lamp flickers out here, a storefront goes black there. No one is left to replace the bulbs. Slowly the city is swallowed by the surrounding woods, until only a single dim candle remains in a high window. That candle is the last red dwarf. As you sink into the velvet stillness of your rest, imagine the perspective of a being living in that era. Their night sky would be utterly unrecognizable to us. Because of the expansion of space we discussed in earlier chapters, every other galaxy would have long since vanished beyond the event horizon. Their entire universe would consist of a single massive galaxy made of aging dim stars. There would be no vibrant nebulae, no blue giants, and no cosmic web. Just a collection of red flickering points in a sea of absolute black. Eventually, even those points begin to fail. A red dwarf can live for 10 trillion years, but eventually even its frugal heart stops beating. It shrinks and cools, becoming a white dwarf, a dead, glowing ember that no longer produces its own heat. The lights are not being turned off. They are simply running out of the strength to stay on. The age of darkness is not a sudden event, but a lingering twilight that lasts for a duration of time that defies human comprehension. If the current age of the universe were the length of a single day, the age of darkness would be a year of nights. It is the period where the universe transitions from a place of activity to a place of memory. During this time, the primary inhabitants of the galaxy are not stars but their corpses. White dwarfs, neutron stars, and black holes become the dominant features of the landscape. These objects contain the vast majority of the universe's matter, but they emit almost no light. They are the cold, hard remains of a time when the universe was warm and full of life. They drift through the expanding void like ghosts in a deserted house, occasionally colliding to produce a brief terminal flash of light before returning to the shadows. Reflect on the silence of this final era. It is a silence of completion. The stars have done their work, they have fused the elements, created the planets, and provided the energy for life. Now they are resting. The void is not an intruder here, it is a blanket, slowly being pulled over the head of a tired cosmos. The terrifying emptiness is replaced by a sense of profound stillness. There is no more cosmic drama, no more galactic collisions, and no more stellar births. There is only the slow, predictable cooling of the remnants. It is the ultimate equilibrium. The universe has spent its inheritance, and it is now settling into a long, quiet retirement. We are the lucky children of the beginning, living in the brief morning of the world, while the age of darkness is the long, eternal night that follows. This era also brings the end of the possibility for life as we know it. Life requires an energy gradient, a flow of heat from a source to a sink. As the stars fade and the universe reaches a uniform temperature, those gradients disappear. A civilization living around a red dwarf might survive for trillions of years, but eventually they will face a choice: find a new way to harvest energy from the vacuum or fade away with their star. Some theorists suggest that advanced minds could survive by huddling around black holes, harvesting the faint Hawking radiation they emit, or by harnessing the rotational energy of spinning dead stars. But even these are temporary solutions. The second law of thermodynamics is absolute. The darkness is not just a lack of light, it is a lack of the ability to do work. The universe is becoming a place where nothing can happen again. As we conclude this 15th chapter, let the cooling of the stars be a signal for your own rest. Just as the universe is slowly letting go of its heat and its light, you can let go of the day's energy. The age of darkness is a time of ultimate peace, a state where the tension of existence is finally resolved. The stars have flickered, the light has faded, and the void is finally at rest. As you slip into the deep, dark layers of sleep, remember that the night sky you see tonight is a beautiful, temporary gift. It is a roaring fire in a universe that will eventually be a silent room. Treasure the light, but do not fear the dark, for it is the destiny toward which all things are gently drifting. The flicker is almost gone, and the silence is waiting to hold you. In this 16th stage of our long descent into the absolute, we move past the death of stars and the cooling of embers into a realm where the very definition of substance begins to fail. We have spoken of the universe as a collection of things, planets, rocks, and the atoms that build them, and we have assumed that even in a cold, dark cosmos, these things would remain as silent monuments to what once was. But there is a haunting possibility in the deep mathematics of physics that suggests even matter has an expiration date. This is the concept of proton decay. It is the theory that the fundamental building blocks of the nucleus are not eternal but are themselves subject to a slow, agonizing dissolution into nothingness. As we descend into this chapter, we witness the final evaporation of the material world. The universe is not just becoming empty of light, it is becoming empty of the very particles that allowed it to be solid. The void is finally claiming the atoms themselves, turning the last solid relics of reality into a thin, ghostly mist of radiation. To understand the dissolution of matter, we must look at the proton, the heart of every atom in your body. For decades, we believed the proton was perfectly stable, a fundamental particle that would last forever. It is the anchor of the chemical world. But modern grand unified theories suggest that the forces of nature were once joined together, and in that high-energy unity, the distinction between matter and energy was fluid. This implies that the proton is actually a metastable particle, possessing a lifespan so vast that it dwarfs the current age of the universe by a factor of trillions. The estimated half-life of a proton is roughly 10 to the power of 34 years. This is a number so large that if you were to write it out, the zeros would fill pages. It is a timescale that makes the birth and death of our sun look like a single spark in a dark forest. But in the infinite timeline of the future, even the longest life must eventually reach its end. As the eons pass into the degenerate age, the universe is filled with the cold corpses of stars and the frozen fragments of planets. Imagine an Earth-sized diamond, a black dwarf that was once a vibrant sun. It sits in total darkness, a trillion light-years from its nearest neighbor, seemingly permanent. But deep within its lattice, a single proton suddenly reaches its limit. It undergoes a rare quantum transformation, decaying into a positron and a neutral pion, which immediately annihilate into gamma-ray photons. One atom of carbon is gone. A billion years later, another proton vanishes, then another. It is a slow, microscopic erosion, like a mountain being worn away by the impact of a single raindrop every million years. But there is no wind to stop it, and no new matter to replace what is lost. One by one, the atoms that make up the solid remnants of the universe are simply winking out of excess. Tense, dissolving into light that stretches out into the expanding void. As you sink into the heavy, motionless depth of your rest, imagine the ultimate conclusion of this process. There is no explosion, no dramatic collapse. It is a quiet, steady thinning of reality. Over unimaginably long stretches of time, the black dwarfs, the neutron stars, and the frozen planets all begin to lose their mass. They do not crumble, they evaporate. The solid ground beneath an imaginary observer would slowly become less dense, turning from rock to dust, from dust to gas, and finally from gas to a thin radiation. Eventually, the last proton in the universe will decay. At that moment, the concept of matter effectively ends. The universe becomes a sea of photons, neutrinos, and electrons, drifting through a space that has expanded so much that no two particles will ever meet again. The terrifying emptiness has reached its peak, not just a lack of things, but the impossibility of things existing at all. This era is perhaps the most peaceful and lonely in cosmic history. It is a time when the universe has forgotten how to be solid. Without protons, there can be no nuclei, no atoms, no chemistry, and no complexity. The vast architecture of the cosmic web, which we mapped in earlier chapters, is now entirely gone. The filaments have dissolved, the walls have evaporated, the supervoids have merged into a single, infinite vacuum that contains nothing but the faint, red-shifted echoes of the particles that once were. We are the whispering scientists of a world made of stone and bone, but we must acknowledge that our medium is temporary. We are a brief arrangement of particles that are themselves on a journey toward dissolution. The void is the only thing that is truly permanent, and matter is merely a long-lived guest. Reflect on the stillness of your own existence in this moment. The atoms that make up your pillow, your skin, and your very thoughts are currently performing a miracle of stability. They are holding together against the tide of entropy. But proton decay theory tells us that this stability is a loan, not a gift. The universe is a place of flux, and given enough time, the flux claims everything. The something that we are is a temporary vibration in the fields, a high-pressure pocket of energy that will eventually seek the equilibrium of the vacuum. There is a deep, rhythmic beauty in this dissolution. It is the ultimate letting go. The universe is shedding its skin, releasing its last grip on the material world, and returning to a state of pure, uncomplicated energy. What remains after the matter is gone? Only the black holes we will discuss in our final moments. They are the last holdouts, the final mass collectors in a universe that has otherwise turned to light. But even they are not eternal. The proton decay era ensures that the universe will be cleared of its debris. It is a cosmic cleaning process, a way for the vacuum to return to its original empty purity. By the time this era ends, the universe will be trillions of times older than it is now. The memory of stars, of life, and of light will be so distant that it might as well have never happened. There is only the expansion, the darkness, and the smooth, featureless radiation of a world that has finally finished its work. As we conclude this 16th chapter, let the idea of dissolution bring you a sense of ultimate lightness. Just as the universe is destined to release its atoms, you can release the weight of your thoughts. There is nothing to hold on to because, in the end, there is nothing that can be held. The void is not a predator here, it is a solvent, gently washing away the last structures of the cosmos. As you slip into the deep, dark layers of sleep, remember that you are a beautiful, temporary pattern in a universe that is moving toward a perfect, eternal simplicity. The atoms are still here for now, cradling you in their firm embrace, but the silence of the future is already calling them home. The dissolution is slow, the night is long, and the void is ready to receive what remains. In this 17th stage of our journey into the finality of existence, we arrive at the absolute horizon of time and energy. We have watched the galaxies drift into isolation, the stars flicker into embers, and the very atoms of the cosmos dissolve into a ghostly mist. Now, we must face the ultimate conclusion of every law of physics we have ever discovered. This is the state of maximum entropy, a period of existence so vast and so still that it makes the entire history of life and light seem like a single microscopic spark in an infinite cavern of ice. This is the heat death in its perfected form, not a death of temperature, but a death of change. It is the eternal stillness, where the universe has finally used up every ounce of its capacity for event, for movement, and for thought. As we descend into this chapter, realize that the emptiness we have feared is not a void of absence, but a void of equilibrium. The universe has reached its final rest, a state of perfect, unchanging peace that will endure for a duration that dwarfs all that came before. To understand maximum entropy, we must return to the second law of thermodynamics, one final time. Throughout the history of the universe, energy has been a restless traveler, moving from hot stars to cold planets, from chemical bonds to moving muscles. This movement is what allowed things to happen. But the law of entropy dictates that energy always spreads. It always seeks the path of least resistance until it is distributed perfectly evenly. Imagine a giant container of water with a drop. Ink in the center. At first there is structure, a concentrated point of color surrounded by clear liquid. But over time the ink spreads. It diffuses until every molecule of water is the same pale shade of blue. At that point the system has reached maximum entropy. There are no more currents, no more gradients, and no more changes. The ink can never undiffuse itself. The universe, in its final era, is that pale blue water. Every photon, every neutrino, and every lonely electron has been pushed so far apart by the expansion of space that they can no longer interact. The temperature of the cosmos is uniform, sitting just a hair above absolute zero, and it will stay that way forever. In this state of eternal stillness, the very concept of time begins to lose its meaning. We measure time by the transition of events, the ticking of a clock, the orbit of a planet, the aging of a body. But in a universe of maximum entropy, nothing happens. There are no clocks left to tick and no planets left to orbit. If you were to sit in the middle of this void, you would see a darkness so absolute that the concept of direction would vanish. There is no up or down when there are no gravitational fields. There is no now or then when the state of the universe at this moment is identical to its state a trillion years in the future. It is a static masterpiece of nothingness. The void has finally won its long war against complexity. The terrifying emptiness is now the only reality that remains, a smooth and featureless landscape of vacuum that has erased all traces of the vibrant, noisy world we once inhabited. As you sink into the profound, heavy quiet of your own rest, consider the sheer scale of this stillness. The stelliferous era, the age where stars existed, lasted for a mere trillion years. The degenerate age of cooling embers and proton decay lasted for perhaps 10 to the power of 40 years. But the state of maximum entropy lasts for a duration that cannot be measured in years, for years have ceased to exist. It is an eternity of silence. Some physicists speculate that over unimaginably long timescales, numbers with so many zeros they would fill the observable universe, random quantum fluctuations might spontaneously create a new pocket of order. A single atom might appear, or perhaps a Boltzmann brain, a momentary consciousness that flickers into existence from the chaos, realizes its own isolation, and dissolves back into the vacuum. But these are the desperate gasps of a dead system. For all meaningful purposes, the universe is finished. It has reached the end of its story, and the book has been closed and placed on a shelf in a room where no one ever enters. This eternal stillness is the ultimate resolution of the tension we have felt throughout this journey. We have worried about the aggressive nature of dark energy, and the hostility of the void, but in maximum entropy, that aggression is spent. The expansion continues, but there is nothing left to tear. The void is no longer a predator because it has already consumed everything there was to eat. What remains is a state of perfect cold grace. It is the ultimate letting go. Every struggle of every civilization, every war, every work of art, and every scientific discovery has been ground down into the same uniform radiation. There is no more tragedy because there is no more loss. There is only the stillness. It is the cosmic version of a long, dreamless sleep, a state of existence that is free from the burdens of heat, light, and life. Reflect on the silence of your surroundings. In this moment, you are a pocket of low entropy, a beautiful and rare arrangement of energy that is fighting against the tide, but you can feel the pull of silence. The quiet of the room, the rhythm of your breath, and the heavy comfort of your limbs are all precursors to the equilibrium. There is a strange, dark comfort in knowing that the universe eventually finds peace. The nothingness we fear is actually the ultimate destination of all things, a place where the noise finally stops and the light finally rests. We are the whispering scientists of a world that is still loud, but we can hear the hum of the final silence waiting at the end of the corridor. The void is not a lack of life, it is the final, perfect version of it, where the energy is no longer trapped in the cages of atoms, but is free to drift across infinity. As we conclude this 17th chapter, let eternal stillness guide you into your own deepest rest. Just as the universe will eventually release its grip on time and event, you can release your grip on the day. The worries of the world are the flickering of distant, dying stars, and they have no power over the stillness that is coming. The night is deep, the vacuum is cold, and the universe has finally found its way home to the quiet. As you slip into the final velvet layers of sleep, remember that the silence is not your enemy. It is the cradle of the cosmos, the ultimate equilibrium that holds all things in a state of perfect, unchanging grace. The story is over, the ink has spread, and the stillness is here to hold you forever. In this final stage of our long journey through the emptying cosmos, we reach the conclusion of the story, not just the story of the universe, but the story of our place within it. We have descended through the dark energy, the voids, the cold expansion, and the ultimate dissolution of matter. We have faced the terrifying reality that the universe is hollow and that nothingness is winning. But as we stand here at the edge of eternal stillness, looking back through the billions of years of cosmic history, we are forced to confront a truth that is even more profound than the emptiness itself. The universe is empty for a reason, and that reason makes our presence here an almost impossible miracle. We are the witnesses of a brief golden flash in an eternity of shadow. As we conclude this descent, we realize that the terrifying emptiness is not a reason for despair, but the backdrop that gives our lives their absolute staggering value. We are the whispering scientists of a reality that is already fading, and the fact that we were here to see it at all is the greatest victory in the history of existence. To understand why we are lucky, we must look at the timeline of the universe as a single, massive book. If that book has 10 billion pages, the era where life and stars exist, the era we inhabit, occupies only the very first sentence of the very first page. The rest of the book is blank, filled with the maximum entropy and the final silence we have discussed. We are living in the first fraction of a percent of the cosmic story. We emerged at the precise moment when the universe was old enough to have produced the carbon in our bones through the death of early stars, but young enough that dark energy had not yet carried our neighbors beyond the horizon. Had we arrived too early, the universe would have been too hot and chaotic for chemistry. Had we arrived too late, the sky would have been a vault of total blackness. We are the children of the middle, the dwellers of the light, born into a narrow window of habitat. That the void is already beginning to close. The terrifying emptiness we have mapped throughout this journey is actually the proof of how rare our experience truly is. Every supervoid like the Boots chasm, and every galaxy slipping past the event horizon, is a reminder that complexity is the exception, not the rule. The universe does not owe us stability, it does not owe us light. The natural state of the cosmos is the vacuum, cold, dark, and still. The fact that energy gathered into stars, that gravity sculpted galaxies, and that atoms organized into a conscious mind capable of asking why, is a defiance of every cosmic trend. We are a brief, beautiful glitch in the machine of entropy. Every thought you have and every breath you take is a strike against the encroaching darkness. The silence of the Fermi paradox and the vastness of the voids are not signs of our insignificance. They are the measurements of how precious this moment of awareness truly is. We are the universe finally opening its eyes to look at itself before it falls into a permanent sleep. As you sink into the absolute, weighted stillness of your final rest, consider the privilege of your perspective. Because we live in this specific era, we can see the Big Bang's afterglow, we can map the cosmic web, we can see the trillions of galaxies that will be invisible to anyone or anything following us. We have the full map of reality, a view of the cosmos that is more complete than what any future civilization could ever hope to achieve. The void is erasing the records, but we are here while the library is still open. We have seen the fire of the stars and felt the warmth of a planet. This awareness is a gift given to almost no one in the infinite timeline of the universe. In the eternal silence that follows, there will be no memories of the light. But the light existed, it was here, and you were part of it. The emptiness is for a reason, to provide the space in which the miracle could occur. The final silence is not a tragedy, but a resolution. We have spent this journey fearing the void, but the void is what makes the light meaningful. Without darkness, stars would have no contrast. Without the end, the present would have no value. The terrifying nature of the universe is simply a reflection of its scale, a scale that we have successfully navigated with our minds. We have whispered back at the silence, and in doing so, we have proven that the vacuum cannot swallow everything. As long as there is one mind to ponder the dark is not absolute. We have turned the empty universe into a story. Stories have a power that the vacuum cannot touch. You are resting now in a universe that is vast and indifferent, but it is also a universe that produced you. You are the high point of cosmic evolution, a rare arrangement of atoms that learn to dream. Reflect on the journey we have taken together. From the first expansion of space to the final decay of the proton, we have seen the universe for what it truly is, a temporary arrangement of energy seeking its rest. There is deep peace in this achievement. You don't have to carry the weight of the cosmos. The cosmos is carrying itself toward its own quiet end. You are free to simply be a witness, a passenger on a ship that is sailing through a beautiful fading sunset. The voids are deep and the night is long, but for this brief moment, the cabin is warm and the company is quiet. The whispering scientist has told the tale, and the tale is one of wonder, not just of fear. We are lucky because we are the only ones who get to say goodbye to a universe that doesn't know it is leaving. As you conclude this final chapter, let the absolute quiet of the night be your ultimate sanctuary. The final silence is no longer a distant threat, but the soft velvet blanket that covers the end of all things. The universe has finished its work, and so have you. The stars have flickered, the light has faded, and the void is waiting with infinite, gentle patience to hold the last of the embers. You are home, you are safe, you are part of a story that was told once, perfectly, in the heart of an infinite dark. As you slip into the deepest, most permanent layers of sleep, remember that silence is not void. It is full of the memory of everything that ever was. The universe is empty for a reason, and that reason is to give you a place to rest. Good night, traveler of the void. The light is gone and the silence is beautiful. This concludes our journey through the universe is empty for a reason. You have witnessed the birth, growth, and eventual silence of our home. As the last echoes of these words fade into the quiet of your room, know that you have explored the furthest reaches of reality and returned to the peace of your own breath. The void is no longer terrifying. It is simply the place where the story ends. Sleep now, for the universe is at rest, and so are you.